So today's exercise is on equivalent fractions. Before we look at equivalent fractions, what we'll look at first is how a fraction is made. A fraction is composed of two parts, a numerator and a denominator. The numerator and denominator tell you two completely different things, and it's important to know what each one means. In this case, we have a fraction 4 over 10. We also write this as 4/10. The th ending refers to the denominator, saying that something is divided into 10 pieces, so 4/10. So the denominator, the actual definition of denominator, is the number of pieces that a whole is divided into. So if the 10 is on the bottom, if we look at this line over here, it means that my one whole line is divided into 10 equal pieces. If I had the number 12 on the bottom, that would mean that I would have 12 pieces. And as you notice, this 12th size pieces are smaller than the 10th size pieces because you are dividing into more pieces. The numerator tells you how many of those pieces do you actually have. So in this case, I have 4/10. So I look first at the tenths. That's the size or the number of divisions. So that is this line here. 4 means how many I actually have. So if I were to color this in, I would have 4/10 of this line complete. If I were to look at the 12ths, and I were to color in 4/12 of this line, I would see that 4/12 is actually smaller than 4/10. The reason why is because my pieces are actually smaller when I divide among 12 than dividing among 10. But I still have the same number of pieces, so in this case 4/12 is smaller than 4/10 if it's referring to the same whole. In this case, we always will be. So now let's look at equivalent fractions. That means two fractions that represent the same amount of space, or in this case, the same amount of line, or chocolate bar as I like to use in class. So let's look at my 4/10 and see where along these number lines I have something equal to 4/10. Well, they all start at the same point, so that's really good. So I can draw a line that goes all the way down and all the way up and see what other fractions match that. Well, I have 5/12. It's very close to 4/10, but not exactly. 11ths, not really. 9ths, 8ths, 7ths, and 6ths, not really. However, if I look at the 5ths, I notice that 2/5 is the same space as 4/10. So I can say that 4/10 is equal to 2/5. So I can use a number line to show that, and I can use other examples as well. But how can I look at it mathematically? Well, what we did here is we reduced our number of pieces, or the size of the pieces, by 2. I divided the bottom number, or the denominator, by 2. That means that I actually reduced my number of divisions, which means I have actually larger pieces. Because I have larger pieces, I don't need as many to cover the same amount of chocolate or the same amount of space. So I have to divide by 2. Let's look at another example. Let's say I had 5/12. What kind of equivalent would I get? Well, instead of dividing by 2, I could multiply top and bottom by 2. So my equivalent might be 10 over 24. Another equivalent fraction might be multiplying by 2 again, and I have 20 over 48. These are all equivalent fractions. Equivalent fractions represent the same amount when you're looking at the numerator and denominator combined.